Hey, it's Paul. Today we're going to look at some unit tests within our Angular applications. So let's make a new application for the purposes of this demo by using ng new, and I'm going to call my project Angular Testing. When that has completed, we can cd into Angular Testing. And right away, if we just run the tests that come along with the Angular CLI, essentially what happens is we get tests written with Jasmine and run with Karma, and we can do this by saying ng test. This will open up the tests inside of the browser, and you can see right here that we have 3 test specs for the app component, and essentially we have it should create the app, it should have the title app works, and the title should render inside of a h1 tag. We also get a depiction of the app component, and we can verify that yes indeed it does have appworks and it is rendered inside of a h1 tag. So let's take a look at the testing spec inside of our browser. So head over to source app and then appcomponent.spec.ts. If you've never done any testing before, this might look a little scary. We have things like describe blocks before each, and then these assertion blocks with it should do this and expect this. At the moment, we are just simply going to gloss over this and make our first test that involves none of the Angular stuff, just simply testing to see whether something is true. So we'll come back to that in a moment. For now, let's simply delete everything inside of this file and start from scratch. So beforehand, we had something called a describe block. So we have this describe here, and what we need to put inside of the describe is a description of the suite of tests that we're going to create. So think of this as the overarching goal for your tests. So at the moment, I'm going to say we're testing the app component. The second parameter to our describe function is the spec definitions, and this is a function. So let's add a new function. And then inside of our describe block, we can declare a new test by using the it keyword. Now it is just a function and it has an expectation. So at the moment, I'm going to say something that's not related to the app component at all. And we're just going to say true should be true, because we're going to test the assertion that true is true. We can now have an assertion inside of our if block, and we can expect that true is to be true. And essentially in this assertion, we're saying true should be true. But before we do that, let's say that true should be false. Now we obviously know that this is not the case, because if something is true, it's not false. But by doing it this way, we can have a test that fails first, and we can then correct the test so that the test passes. If we save the file and take a look back inside of our browser, we now have the new spec that we created. Now because we deleted all the other specs, we only have the true to be true. So this spec right here, which says true should be true, has failed, and that's because it expected true to be false. If we instead say that true should be true, we now get a passing test that says true should be true. So this right here is the basis of our testing going forward. We're simply going to have a describe block which describes the suite which we're testing. We have it blocks which perform a description of the assertion, and then within those it blocks we make the assertion to see whether something should be the value that we expect it to be. Now at different stages of our testing lifecycle, we also have things like before each. So this, during the before each stage, would be setting up the test to have particular states beforehand. We also have things like after each to reset the state of stuff that we do inside of our tests, but for now let's simply make a new component and investigate these concepts a little bit further. So let's generate a new component named the counter component. We can do that by saying ng-gc, which is ng generates component counter. This will be automatically added to our app module. So all we need to do then is head over to the app component and instead add our app counter to our app component. So before going any further, let's delete everything inside of the describe block within our counter component spec. simply leave the imports and this describe counter component. So let's make a template for our counter components, and that will simply be a paragraph tag, the word number, as well as a colon, and then we'll have the current number of the counter. We'll also have two buttons. So button 1 will say increment, and button 2 will say decrement. Both of them will have a click event named increment, and the second one will also have a click event named decrement. If we then implement these functions by saying we will have a counter, and that will be of type number, the initial value for the counter will be 1. Inside of our increment function, we can simply increment the counter by 1, and for our decrement, we'll simply minus the counter by 1. So we have a very simple component that displays the counter number, and we also increment it by 1 or decrement it depending on whether we click the button. So to check everything works before going forward, let's run ngserve and check it out inside of the browser. As you can see right here, we have a counter with a number of 1. If we click that, we get 2, and if we decrement the counter, we get 1. This can be done as many times as you wish, so we could continuously increment or continuously decrement. Let's now write some tests for our counter component. So inside of our counter component.spec, we can start off by firstly removing everything inside of the describe block apart from our component and fixture. Inside of our describe block, we have our reference to the counter component. And then we have something called a fixture. So a component fixture is essentially a reference to our component with a few other methods added on. These are things like detect changes, which allow us to perform change detection from within our tests. We can also access things like the native element, the component instance, and a few other things that we'll take a look at in a second. So the first thing that we have to do is declare one of the before each blocks that we were talking about earlier on. Inside the before each, we'll be declaring a new testing module, and we'll be importing our counter component into the testing module. So let's write before each, and then inside of the before each, we need to perform an async action. So let's write async, and inside of this function, we can simply say testbed, which is the testbed that we've imported from Angular core testing, and this provides us with different things such as a new module, which we'll create in a second, .configure testing module, and this module is created just the same as any other module would be. So we can have a declarations, and inside of the declarations we can add our counter component. And the reason we have to call this with async is because we then need to call compile components. And what this does is it waits for our asynchronous templates to be loaded, such as our counter component.html, our counter component.css, and so on. We can then have another before each block, and in this before each block we'll do things like setting up our component. So far we've simply said that we have two variables here, one named component and the other one called fixture. Now at the moment we've yet to initialize them. We've simply said they are either type of counter component or type of component fixture. So let's now say fixture is equal to testbed.create component. Inside of the create component method, we can pass our counter component. This gives us a testing version of our counter component. We can then get an instance of that testing component by saying component is equal to fixture.component instance. You'll notice that already we could type component, and then on our component we have access to things like the counter property, the increment function, and the decrement function. We'll not need to use them yet, but we will very soon. So the first test that I'm going to write here is to assert that the counter component simply states the current number of the counter. So we can say it, and then our expectation should be written in English, so it should display the current number of the counter. After our expectation, we're going to have an assertion function. And in here, we need to assert that the text on screen is equal to a particular value. So how might we do that? Let's for now add a comment. Assert that the text on screen is of number 1. So to get reference to that, we'll have to create some more variables. The first thing that we have to do is get access to the debug element. And that debug element comes from Angular core. So let's import from @Angular/core the debug element. And we can say let debug element is of type debug element. And when we use the debug element to get a reference of what will be the paragraph tag that says number 1, we'll want to get the native HTML element within that element itself. This will become apparent very soon, but for now let's simply make a new variable named HTML element of type HTML element. And the final thing that we need to import is something called by. And by importing by, it allows us to query on a particular element. For example, if we import from @Angular/platform-browser, we can import by. And because we may be checking the current number on a few occasions, I'm going to put this in the before each. So we'll start off by saying that the debug element is equal to the component fixture dot debug element, and then we can query the elements within that component's DOM and say by. So we're querying by, and we'll say everything that matches the CSS, and within the CSS selector, I'm going to say P for paragraph. And if we take a look inside of our component, at the moment we have the 1 paragraph tag, and that paragraph tag simply says number, and inside of that number is a counter. So the counter is going to be the value after or before it has been incremented or decremented. So now that we've got access to that debug element, let's get the native HTML element for that query. So we can say HTML element is equal to the debug element dot native element. We now have a hold of that queried HTML element. Because of that, we can now assert that the text on screen is of number 1. And that's because that's the default number for our counter. So we can say expect that the HTML element and the text content of that element is equal to number 1. But to make this fail first, so we can check that our test is actually doing what we expect it to, I'm going to say number 2. Notice now how we do get that error first, but there's something a little bit off with the error message. It's saying expected number, and then we don't actually have a number here to equal number 2. And this is because we currently don't have any change detection implemented within our test. We can handle change detection within Angular in a couple of ways. We can leave it up to Angular to do it automatically, or alternatively, we can do it ourselves. By leaving it up to Angular, anything that's asynchronous is caught by the change detection. Anything that's a synchronous change to the value is not. Let's take a look at how we can use change detection within our tests. So when we initialize our component, let's then say fixture.detect changes. If we read the description, it does say trigger a change detection cycle for the component. And if we look inside of our component, when we are initializing the component, we are saying the counter is equal to 1. So when we don't actually call that change detection, that counter is not being initialized to 1. If we save our file and look back inside of our browser, we now get the error expected number 1 to equal number 2. We can now see that our assertion is working correctly. We've expected number 1 to equal number 2. So let's say number 1. We can now see that all of our tests currently pass. We are displaying the current number of the counter, and we have number 1 here. Let's now make a new test, and that test should increment the counter number by 1. So let's say it should increment the counter number by 1. Can make an assertion function. And the first thing that I'll do is I will arrange my test, and I will get the current value of the component's counter number. So we can say initial value is equal to the component.counter. And as we know, that's currently equal to 1. Let's now act on our test. And we can, of course, call the component.increment. And that's going to increment the number of the counter by 1. We can then capture the new value by saying the new value is equal to the component.counter. And then our assertion here would simply be that the new value is greater than the initial value. But let's make it fail first by saying the initial value should be greater than the new value. And yet again, we get the expected 1 to be greater than 2, which we expected. And if we put that back, so we now have expect the new value to be greater than the initial value, we now get our passing test of the number being 2. However, on the screen, our change detection doesn't seem to have kicked in. So let's make sure that our tests are, of course, detecting any changes after we increment the value within the component. If we then click the counter component and say it should increment the counter by 1, we click that, we have the number is equal to 2. But if we remove the detect changes and click the increment counter number by 1 again, we don't have our number equaling to 2 on screen. So it's a good idea to implement detect changes whenever you're making any changes within your tests. I'm going to clean this up a little bit so we can see the screen. And then I'm going to copy this, and instead we'll say it should decrement the counter number by 1. So we can say component.decrement, and if we save the file and run it as is, we have our initial failure expected 0 to be greater than 1. And now we can say that the new value should of course be less than the initial value. And once we do that, we do see that the decrement does work. I seem to have lost my detect changes, so let's detect the changes once again. And instead when we click it, we do see that our number is 0. So hopefully you're seeing right now that initially we have some boilerplate to deal with, such as before each and importing all of our dependencies. But when we actually get into it, it's quite simple to test our components. Now right now we have a simple example of a counter, but in future videos within the series we'll take a look at making things a little more complex, looking at services and so on. Finally, I want to write 2 more tests, and these tests are going to be after the number is incremented, is the correct number shown on screen, and after the number is decremented, is the correct number shown. So this one is quite simple. We can say that this test should display the counter number on screen after being incremented by 1. To keep this video short, I'll simply say that we will first off say component.increment. We'll then capture any changes by saying fixture.detect changes. And obviously I'm aware that at the moment it will pass if this is number 2, but if this number was to become 3, our current assertion here, which would be should display the counter number on screen after being incremented by 1, would not technically be correct, because once that becomes 3, it no longer equals number 2. So this is an important point, that when you're actually testing your components and you're designing tests, it's important to make sure that the test actually accurately represents what is happening. But to keep this video short, let's just test for that. We can also test for the fact that the number will be decremented by 1. So the number should equal number 0. And we can say component.decrement. If we then run this in the browser, we do get indeed 6 passing tests. But if we were then to say component.increment, and instead we called that twice, our test now fails. So it's important, like I said, to be quite specific on the functionality that you're testing. I hope that this video has proven a good introduction to testing within Angular applications. My name is Paul Halliday, and if you haven't seen already, I have a Learn Ionic 3 from scratch course over at Udemy. There's a discount code in the description if you want to catch that while it's in early access. Don't forget to hit that subscribe button to stay up to date with the latest content, and until that time, I'll see you very soon in the next video.